Okay, good morning, everyone, and welcome to our second session on DNS security. This is part two, just for information. We've had part one. If any of you have missed the part one, please visit our YouTube page, Sri Lanka Cert CC, or our Facebook page, and we have the recording of the first session. And today, we're going to have the part two session, again by a good friend, Mr. Champika Wijayatunga. So this is going to be DNS security part two. So we're going to cover things like DNS threats and abuses, best practices in securing DNS, incident response, and a little bit of an overview on DNS security. So with that, let me introduce our speaker today. Champika is an experienced cybersecurity professional, currently working as a technical engagement manager for Asia Pacific region at ICANN, the global body that coordinates internet unique identifiers across the world. Prior to ICANN, Champika had held specialist and liaison role at APNIC, the regional internet registry for Asia Pacific. He started his career with IBM Corporation as a technical specialist and worked in IT industry, academia, research and training environment. Champika holds a postgraduate degree in computer science and engineering and professional education qualification in cybersecurity, and also serves in various technical community groups and committees. Champika has been regular speaker at various technical and security forums, Interpol, Council of Europe, and etc., and also received a number of experience awards during his career, academic and professional career. So with that introduction, let me welcome Champika Wijayatunga, and it's over to you, Champika.
Yeah, thank you, Alan, and thank you all for joining with us today. So as Alan mentioned, this is the second part of our DNS security training. And I think about a month ago or so, we did the first part. And so in case if you have missed that first part, I would highly recommend that you visit the recordings and the videos that Alan just mentioned. And also, but you know, it doesn't matter if mainly if you are new to DNS and so on, it is worthwhile to go and have a look at those videos. But in case if you are familiar with DNS, I think you should be okay. So because I will not be going and discussing about some of those fundamental things today, which we have already done during the last session. So what our plan today is actually to discuss, this is the agenda that we are planning basically to discuss today. So you can see that during part one, during the last session, we went through, we had I gave an overview of DNS. Just to sort of, quickly recap, it is, I did mention it, you have a namespace, then we have name servers, and then we have resolvers or clients that query the name servers and asking questions about the namespace. We also went into details about DNS servers, different type of DNS servers, like resolvers or recursive servers. We also spoke about authoritative servers. And then we also actually spoke about root servers. I gave some good understanding about, how the DNS queries work, how the queries go to root, and where these root servers are located, and so on. Then we went on to further, understanding about DNS data. Basically, inside these databases, inside the namespaces, what kind of data do we have, and also how this data is all organized, and and then how do we deal with this DNS data. And then also, finally, we ended up with a very quick, brief overview of DNS security, highlighting why we really need DNS security. Why DNS is not really secure enough, and why we really have to consider implementing or deploying security mechanisms within DNS. So these were the things that we sort of went through last during the last session. I hope that in case if you are joining for the first time, or even if you have joined the last time, if you wanted to get a quick recap, hopefully this would help you. So today our objective is actually to go through into more details of different type of DNS threats and abuses, and then what are the key practices in trying to secure the DNS, and then also we'll touch on the incident response aspect, in case if you're dealing with these cyber incidents and so on, especially related to DNS, what are the things that you need to understand. And then also we will give a sort of a brief understanding of DNS security extensions, or simply we call this as DNS Sec. So that's the plan for today, and then we still have one more session to go. As I said, I will come to the questions in the end. But if you have any questions and so on, you can probably discuss those during end of the session, and just to sort of so that we can manage the time properly, and so you can hold on to those questions. All right, and so let's go into the session. So we're going to talk about DNS threats and abuses. Now, speaking of DNS threats and abuses, if you remember the other day, I explained you how a DNS query gets resolved, right? I mentioned to you that, we have the client device, we have things like stub resolvers in the client. So the client would send a query to the recursive resolvers, typically operated by the internet service providers or ISPs, or could be even corporates, or it could be even open sort of public DNS resolvers and so on. So the query goes there, and then those recursive servers would then send the query to different authoritative servers like root servers, top level domain servers, and next level servers and so on, and then find the data, and then this data will be returned back to the client. And then this data that recursive resolver gets will be cached or kept in the memory of the recursive resolver, so that the client can get the answers very quickly next time, because once the query is done, that those answers are in the cache of the recursive resolver. So the next time the queries are much faster. I mean, the responses are much faster. Yeah, so we went through that process. Now, when you think of that whole, the DNS infrastructure, or even considering the protocol level itself, we need to understand few things. One thing is that, in fact, the other day also I gave kind of a brief historical overview, how the DNS was evolved from a historical point of view, what we had during early days of DNS and so on. So DNS was designed about 40 years ago, right? Quite a long time ago. And during that time, of course, during the design of the protocol itself, security was not much of a key objective during that time. So that is why we don't see some of the security requirements, what we have today, are not really built in to the DNS protocol itself, right? So this is why actually now we have to really consider deploying security mechanisms in DNS. So there is quite a large attack surface when it is related to DNS, because DNS infrastructure is kind of publicly facing. So when I say publicly facing, which means basically it is a public database, right? So if you consider a zone file, which actually you have all these mappings, and then one can query those records in the public DNS. So this is why I'm trying to say that it is more of a publicly facing infrastructure, and this is also why we really have to protect our DNS. And the other thing is that the whole DNS ecosystem itself is quite complex. Why it is complex? Mainly because there are so many players involved. It's not just one organization as such. I mean, you could be having your own DNS space. Say, for example, if you have a certain domain, a domain name for your organization, so you have you are responsible for a certain space. That is fine. But if you consider the whole DNS as a whole system itself, there are so many of other players. If you remember that even last time I went through things like registries, registry operators, I went through registrars, resellers, and then registrants, and also recursive resolve operators, authoritative serve operators, root serve operators, and so on. So there are many parties involved in managing DNS. Of course, some parties are involved in managing the administrative aspects, and then some parties or some entities are involved in managing the technical aspects as well, the infrastructure, the operational aspects. So there are many players in DNS. So this is also why actually the DNS gets very complex, especially if you have to deal with it, if you have to deal with some incidents and so on. There are many parties that you will have to deal with or collaborate with. So the whole idea, what I want to actually let you know is that DNS is a publicly facing infrastructure, and also there are so many players involved in the whole ecosystem, so the things get quite complex. And also the other thing is, as I said, during early days, about 40 years ago, when the protocol was designed, many of the security requirements what we have today, it was not really built into the protocol. So because of this, nowadays, it is possible for some miscreants or attackers to get advantage over some of those loopholes, and then try to attack DNS or create some risks and threats on DNS. So this is why we really have to understand those and then try to protect those loopholes. Okay, and then speaking of queries and responses, now data integrity again was not originally built into the protocol itself. So there is no protection against things like data corruption, because the integrity, say for example, you get the recursive resolver talks to an authoritative server, right? If you remember that we went through a diagram as well last time. The recursive resolver goes and talk to an authoritative server, like a root server, could be even TLD server, and so on, and it gets this data. So when we get the data, something can happen in the middle. So basically, man in the middle type of attacks can happen. So someone can capture this data, and then this data can be modified in the middle, right? So in case if it is modified in the middle, the integrity of the data will be lost. So unfortunately, the protocol itself will not provide us some protection against those kind of changes, or in case if the data get changes in the middle, we don't have a protection in the protocol itself to fix those. So that is why we have to have some security mechanisms to fix those things. Then again, considering the confidentiality aspect. Now, in a typical system, right, when we say it is a secure system, we expect few things. We expect things like confidentiality, integrity, right, availability, and so on, right? So these are key things that what we expect out of a proper secure system. Now, even in DNS, the queries and responses, you don't really have confidentiality factor there. So by that, what I'm trying to say is that when you send a DNS query, say for example, when you visit a certain website, right, in your device or in your laptop, in the browser, if you visit a certain certain domain, for example, this is in the DNS query itself, right? The domain name, and this query is actually sent in clear text. So which means, if someone capture this data or this bit stream, basically knows that exactly what is, which domain that you're visiting and so on. So this metadata can be actually captured. And also even for recursive server operators, say for example, when you send a query from my device, say to my ISP or recursive server, obviously the recursive server operator, the ISP, they know exactly, what sort of domain that I'm querying and things like that. So these are all in clear text, right? So this is why we are trying to say that there's no any confidentiality factor involved when it regards to the queries and responses, right? So simply, I would say that, okay, privacy is something that we have to handle in DNS, right? It is not provided by the protocol itself, okay, the original design. And then, so we spoke about data integrity, we spoke about confidentiality. These are not really built into the protocol itself. So we have to apply some security mechanisms if you want to protect against those. And the other thing is also actually, there are quite a lot of namespace risks involved. So what do you mean by namespace risk? Say, for example, that when you get a domain name, right? Say in your organizational domain or something, right? When you have your own domain, you have to really take care of your namespace because you are given a certain space, right? So this is basically your database. So whatever happening within that database, you need to take care of that. You need to protect that. You can, of course, sub-delegate part of your domain to another party. That is possible. So if you do sub-delegate, give part of that to another party, then whoever the other party, they have to basically take care of those. So anyway, your namespace you have to look after. Now, when it comes to this namespace, simply the domains, there are some risks involved or threats involved. If you see here, there is something called homoglyphs. So what are these homoglyphs? Nowadays, again, if you go back to what I was explaining, if you remember, I showed you a tree hierarchy, proper structure. We have root on the top and then TLDs in the top level domains and then next levels and so on. Proper tree hierarchy in the DNS structure, right? The database structure. So when you get a domain, there are also actually there are also possibilities that we can have domain names in say for example local language scripts, right? So these are called internationalized domain names. I did explain about this last time. So internationalized domain names are basically have the domain names not only just in English characters, but also in local language scripts. Say, for example, from Sri Lankan perspective, it could be a domain name in Sinhala or in a domain name in Tamil, for example, right? So these are local language characters. But DNS will not be able to obviously understand these local language scripts because DNS queries and responses, they're all based on ASCII characters, right? So we have to convert these local language scripts into ASCII characters or a code. So when you have some internationalized domains, sometimes some of these internationalized domain names might exactly look, right? I'm talking about the look and feel here, right? They can look like an English domain, or sometimes maybe with a small difference, right? So if you see this example that I'm showing here, you have example.com here, right? So this is in English and this is in ASCII characters. But if you see here example.com, you can see the E here. has got an accent. So it is actually not English E. It is actually in a different script, because some of the scripts, say for example French or something, they have some characters with an accent. Okay, so if you consider the ASCII domain of this, right, this string, it is this one, right, X and hyphen hyphen, this whole thing. You can see that this is a ASCII code. So in actual fact, even though this domain is example e with an accent.com, the actual ASCII code refers to this, right? So if you just show this to a user sometimes, especially if you're looking at this domain in a, say, in a small screen in a mobile phone or something, you would not really notice much about this, this little accent over there, on top of this E, right? So simply a user might just think this as EnglishExample.com, right? So this query, the problem is that there are totally two different namespaces. So if you consider this example.com versus this example.com, they are two different namespaces, right? Two different locations, two different name servers. So you might think that you are going to example.com, but in actual fact, you could be going to a wrong place. So this can be always a possibility. And also similarly, this one is even worse. This one actually, the accent you can see, with the little e, in the e with the little accent, you can see that. But if you consider this, it is not possible for us to differentiate because this exactly look like this. But actually here, this A is actually is not an ASCII A here. In this second part, this one, this A here is not really an ASCII A, right? Again, it's there. It's from a different script. So which means, say for example, some of the, if you take two languages, say in English or Cyrillic, Russian, there are some letters, they look the same, right? They look the same, but of course the Unicode is different. So if you really consider this example.com versus this example.com, this will resolve as example.com, but this will resolve as this xn hyphen, example, like this. So you can see that because this is the ASCII code for this one. So now you can see that, it is quite easy for some miscreant or some attacker to easily, have some sort of a phishing site using some internationalized domain names because the look and feel is quite pretty much similar. It is, for a normal user, it is very hard to differentiate between these, and then a normal user can really go into a wrong place when they see this sort of domains, right? So this is why I was just trying to explain there are namespace risks involved, right, in the DNS. And also there are things called typo-squatting. Typo-squatting is that we may want to type just example.com, but we may end up in just, just because, typing mistake, we may type, instead of typing EXAM, we may type EXMA, right? Just, two letters swapped. So now when you type like this, obviously example.com versus this one is two different namespaces, two different databases, right? The queries will go into different places. But then whoever owned this, say, if whoever operating this authoritative server is doing it in a bad intention, they can try to have, similar looking website to example.com, and then they can have a phishing sort of, site over there, and then try to basically, get the advantage over the user. So these kind of things are always possible in DNS. So these are all different risks involved, okay? So moving further, there are quite a lot of more risks as well. Now there are things called redirections. So redirections are basically again, changing the DNS servers. Last time we spoke about different type of DNS servers, right? So even the authoritative servers can be pointed to attackers' authoritative servers. Again, this can be done by various ways. For example, like cache poisoning. So cache poisoning is, if you remember in the recursive servers, the answers are kept in the memory. So in case if we manage to, if the attacker managed to poison or pollute the cache in the recursive server, it can redirect the query to a wrong authoritative server. And this authoritative server could be controlled by the attacker, right? So this is always a possibility, right? The redirections. Resolver hijacking. Now, resolvers are operated by, again, as I said, sometimes it could be operated by the corporates. Sometimes these recursive servers could be operated by the internet service providers, ISPs, mobile operators, and so on, right? And these resolvers could also be hijacked. So when I say resolvers could be hijacked, say I have in my mobile, say for example, I have my resolvers are configured as my mobile server operators resolvers, right? So whatever DNS queries that I'm doing, say I'm visiting any website or I'm using any mobile app or something like that, those queries now will go to my mobile operator's recursive servers, right? That is fine. I trust my mobile operator and I trust their servers, I trust their infrastructure, so it's all okay. But sometimes, say for example, that in case if I visit a malware site, so the attacker could probably create some phishing email, and then if I just click some link and then I get to a certain malware site, right? Or even there are so many of these kind of malware sites out there in the internet, right? So you might just visit a malware site, and then the malware could get downloaded into your device. And then once the malware get downloaded into your device, the malware could do all sort of things. Say in case if it managed to change your DNS settings in your device, now the queries are not going to your ISPs or mobile operators DNS servers, right? The recursive servers. Because your local DNS settings are all changed now by the malware, the queries will go somewhere else. So this is what we call resolver hijacking. So you think that you're going to your ISP or mobile operators resolvers, but in actual fact, your queries are not going there. Your queries are going to a recursive resolver operated by an attacker, for example, right? And the attacker is the one now going to give you all the answers. So the attacker could give you, say, if you're asking, give me www.mybank.com, you want to visit your bank and do some banking transaction. So you might want to get the IP address of your bank web server, but the recursive resolver operated by the attacker can always give a wrong IP address. So if you are given a wrong IP address, you will go to a wrong, obviously a wrong website, and then this could be again a phishing site, exactly operated like the bank website, and then you might end up in giving your credentials. I mean, these things are very common type of attacks. A lot of users get caught to social media sites. They go and try to give their credentials, ID and passwords and things like that, and it's quite easy to capture these things so that that you might even lose your social media accounts and so on. Okay, so resolve hijacking, and also sometimes nowadays, especially nowadays, we use internet in so many public, different public places. We could be using say the hotspots in airports or train stations or restaurants and things like that. And in most of these places, they provide the connectivities, they provide the hotspots, the Wi-Fi access, and so on. Sometimes you may get free Wi-Fi access. So a lot of people just try to connect And then when you connect to those networks, you have to remember that, all your queries are going through someone else's infrastructure, right? Say they could be providing you the resolution service, resolver service. So that means you are asking some unknown server which cannot be trusted, that you want your bank website or whatever, right? And so these kind of things also expose us to lots of these sort of hijacking, resolver hijacking issues as well. Okay, and these are all different type of attacks that abusers, threats that you will find in DNS. Denial of service. Now, the denial of service is simply we call DOS, or when you try to multiply this or make it much bigger, we call it DDoS, or distributed denial of services. Now here, the attackers or the miscreants, they can also try to get advantage over, say, the recursive server operators, especially if they operate some public, say, open resolvers. Say, when I say open resolvers, consider that I am a recursive resolve operator, right? Say I'm your ISP, okay? I'm your ISP and you are my clients. So if I am operating a recursive resolver, I should not be operating what we call an open resolver. Open resolver means I am happily answering any queries that are coming from anyone, right? So it could be my customers, or it could be just outside parties. Whether it is outside parties or whether it is customers, I'm still happy to answer queries for them. So this is what we call an open recursive resolver. This is, if you are doing this, you have to be very careful, right? Because you can get all sort of queries from outside parties, and then someone else, especially an attacker, can try to use your behavior towards creating some DDoS towards another server, right? Say, for example, an attacker could spoof the identity of a web server, for example, or any server, right? Any victim machine, and then can ask me simply, a question, give me www.something.com, for example, very simple DNS query. And then I will go out to authoritative servers. I could be going out to root servers, TLD servers, other servers, and so on. And then I will find the answer. And then that answer will now be returned to the victim, right? Not to the attacker, because even though the attacker is asking me the question, the attacker has spoofed the identity of the victim. So my response will go to the victim. So now you can see that unnecessarily the victim server will get some response from me. And if you really consider the behavior of DNS queries, sometimes in DNS we can ask a very small question, but we can get a large response. The way that you ask, different type of questions, different type of resource records, you can ask, maybe a very small questions in terms of the bytes, the size, and then expecting a much larger response. So in that case, obviously, the response that I'm sending to a victim server is much larger. So if these questions are being asked repeatedly, I will be sending responses repeatedly to the victim. So which means victim will get a lot of load within a short time. And also if the attacker managed to talk to many other servers like myself, I'm considering here I'm an open recursive resolver, right? So if there are a lot of out there, I mean, in fact, actually in the internet, there are millions of these open recursive resolvers out there. So if the attacker managed to talk to so many thousands of those servers, and then redirect, or basically send all those responses to a victim server or a victim machine, suddenly within a very short time, the victim machine will get a large amount of responses within a very short time. And then that will consume all the resources in the victim machine. It will consume all the bandwidth. It will consume the the CPU memory and so on, and then it will not be able to function. So this is what we simply call a denial of service or DOS attack. So you need to understand, because someone is just running some open recursive resolver, these kind of attacks can be carried out. So this is also why, especially if someone is running any resolvers, you have to have some proper best practices in terms of trying to protect your recursive resolvers. Impact of hierarchical namespace. Now, these are also, actually, there are some threats here as well, because DNS is a hierarchical namespace. So when I say hierarchical namespace, if you remember that, you have root on the top, then the TLDs, then the next levels, and so on. So in case if a higher level is being compromised by the attacker, the lower levels are also exposed, right? Say you have your company domain, okay? Say you have your company domain, say xyz.com, right? xyz.com. And then you might be having a subdomain, okay? So subdomain could be, say, sales.xyz.com, right? So all your marketing department, the sales department, they could all be running their sales campaigns and that and this and everything over there, okay, in that subdomain. So if the attacker managed to compromise, say, the xyz.com, obviously even the sales.xyz.com is also, actually, because it's a delegation out of that, and that is also under threat now. So anything underneath that namespace will be under risk, right? So this is why, actually, compromising higher layers means there is a potential compromise of that layer and all the lower layers below that, right? So these are all different risks that you can have in DNS. So what else? Then there are other issues, right? There are other threats and abuses like registrant compromises. So this is where, if you remember that last time we went through some terminologies, we went through registries, we went through registrars, we went through registrants and so on. So when I say if I want to get my own domain, I become the registrant, right? If I want to get my own domain, I become the registrant. Now, when I get my own domain, typically my registrar, they would give me some sort of a portal access, could be a web portal, right? So that I could log in and I could provide my DNS, information. Say, for example, my name server details, my various records that I'm adding, my web server, mail server, things like that. I would add all those things through that portal, right? So that those records will be then saved in the DNS zone. So I have that access to that portal. Now, if my credentials for that portal is being compromised, there can be various ways again, right? So someone could be just, someone might steal my credentials, or someone could actually, through a phishing type of attack, they could still try to compromise my credential. Any of the ways they could try to compromise my credentials, and then they can gain access to that portal. So if they gain access to that portal, they can change quite a lot of things. They can change my name servers. They can change my web servers. They can change my mail servers, all the IP addresses, things like this can be changed. So, and then they can also change the credentials, they can change the passwords and so on. To make it worse, even they could transfer this domain from one registrar to another registrar as well. So then you will totally lose control to your domain. So just imagine, you are from a bank, and then suddenly you lose control. You no longer own your bank domain anymore, right? So just imagine the situation, and then how critical that would be, right? So this is why it is very important that, especially consider all these factors, especially if you're managing your DNS, or even if you're outsourcing, because many companies would outsource DNS services to another party, to a third party. And if in case if some compromise happen like this, what are the factors that you are going to consider, or what sort of service level agreements that you're going to have with that other party whom you're going to outsource, right, to fix these issues and things like that. So all these are what I'm trying to point here is that all these things can be risks or threats and abuses in relation to the DNS. And then, so I was just talking about registrant compromises. Registrar compromises can happen as well. So your credentials is all fine, but just in case if the registrar systems were not properly secure enough, maybe the attackers could get into registrar infrastructure, maybe their systems were compromised, and then not only my domain, but also many other domains could get compromised as well, right? So the problem is even worse. That can be even worse if in case if there is some registry compromise, because registry is even above the registrar level as well, because then the severity is much more. So these compromising can happen in different levels. So this is why we have to make sure that you could be, I'm not sure which organization which type of organization that you are coming from. You could be a normal user, you could be a internet service provider, you could be a registrar, you could be a registry. Whatever the case, you need to make sure that whatever the DNS infrastructure which is relevant to you should be protected, right? Then there could also be DNS software vulnerabilities, because we in all these DNS servers we run different name servers, different software, right? And again, if you are sometimes, as you all know, the software can have some vulnerabilities, some bugs and things like that. So in case if something like that, if some attacker managed to actually find some vulnerability and then try to take the advantage over that, then there is some risk involved there as well. This is also why actually, especially in some organizations, if you're managing many DNS servers, say you have multiple DNS servers, it may be a bit risky if you are going to have the same name server software across all your name servers, because in say you have number of name servers, but you are running the same DNS software across all your name servers. So in case if there is some vulnerability, you're going to affect all your name servers, right? Because that same software is running in all your name servers. So good practice would be, have some change, have some differentiation, right? If you're running some particular DNS name server software in one of the DNS servers, maybe in the other one you could run another different type of DNS server, right? So have some variation, so that in case if there is some vulnerability, then you're not affecting all your name servers. Okay. All right. So moving forward. Now, this is again just for you to get some sort of a graphical view of what we have been talking, because typically in a DNS infrastructure, you will find many components, right? Many players. And many parties involved. As I said, it is just not only one party who is managing everything. There are many parties involved. So we have stub resolver. This is basically the client, right? You're running your client operating system. And then we have recursive servers typically operated by our ISPs, mobile operators, public resolvers, and so on. And then they go and talk to various authoritative servers out there. And then there are registries, there are registrars. So there are some communications happening between registries and registrars. There are certain protocols involved, especially if a registrar is managing a lot of domains, they have to have some certain protocols running with the registry to make sure that these delegations are this domain name assignments are properly done, and so on. And then we also spoke about clients, the registrants. Registrants get access to some portals, right, interfaces, so that the client, the registrants can update their DNS information in this registrar database, and ultimately it will go and update the registry database. So there are various parts into this whole thing, and in all these places where you see these crosses or X red crosses, there are always possibility of target potential target points in all these places, right? Someone can target your infrastructure in all these places. And but of course, when you go inside, say, I'm here considering one system itself, but if you go here, even between these authoritative servers, there could be some potential target points as well. So this is why you have to consider the whole DNS system as a whole, and then try to protect it. I mean, you could be only one party in this whole thing, but you have to make sure that, of course, you are doing the right thing, and also make sure that if you are dealing with other parties, or if you are outsourcing certain functions to other parties and so on, at least you have some awareness what you have outsourced and what are their responsibilities, what are your responsibilities, where the things can go wrong, and in case if something happens, how you're going to deal with it, and so on. Okay. All right. I also actually want to quickly show you to show you what's happening in the real world, right? So we spoke about many things. We talk about different type of attacks that happen and so on. There are quite a lot of these things happen, but I wanted to show you some real sort of statistics so that you know that these things what we are talking about is all real. And so in ICANN, we have been doing some measurements, especially in relation to these domain name abuses and security threats. So we have actually a system called DAAR system, right? So DAAR stands for domain abuse activity reporting, right? So we try to measure different type of abuses. We are focusing on four specific abuses here. One is actually phishing, malware, spam, and botnet command and controls, right? So over the last 3 years, you can see, based, we do this we do this continuously, and then we produce monthly reports so that, anyone can see exactly how these, what sort of reporting is occurring, in each month, right? So if you try to get the sort of, whole total figures for the last 3 years, and then try to plot all those things, all those different type of threats, you can see here that there is, over the period of time, right, over the last 3 years or so, there is actually increase of phishing, right? So I mean, of course, in some months it's high, some months it's low, but in general, if you see the plot, there is some sort of increase, right? There is some increase over the last few years. Same with malware as well. So that means that these basically, domain names are being used to create phishing attacks, or domain names are being used to host malware and things like that. Is why you will see it is kind of increasing. So if you consider now versus 3 years ago, now there is an increase comparing to 3 years ago. Spam has dropped. You can see, spam has dropped mainly because a lot of organizations, they have spam. They tend to spam, you have spam filters, a lot of service providers and so on. They have spam filters and so on. That is why spam, you will see over the period of time, handling spam is getting better and better. But then if you consider the other stuff, other abuses like phishing, malware, or even botnet, there is some increase over the period of time. So this is also why you have to be very careful, especially if you are getting your own domains and if you're running your own domains. If you already have your own domains that you're managing and so on, be aware of what's happening with your domain, right? Okay, and especially now, I thought we are talking about DNS abuses now, all these domain name related risk threats and so on. And also we are into the COVID-19 period. So I thought maybe I will also take this this particular time period, especially because of this COVID-19 incidents. I will try to explain.
Champika? Hello? Can you hear me? Hello? Hello, Champika? Uh, Hi everyone. We're just experiencing a bit of a technical issues, and the speaker will be connected shortly with us. So please bear with us for a couple of minutes. Thank you.
You hear me now?
Yes, Champika. I think when you want, we just lost you all of a sudden, but glad that you're back.
Yeah, not
So
sure
if you
what
could,
happened. Not
okay,
sure it's something to do with the application, but I restarted the whole thing.
okay.
Where did you
Let
lose
me
me,
tell you, I
right?
think just after the abuse and threats, the new slide that you went on to, the new part of the
Did you
section.
hear about COVID-19? I was
No,
talking about
no,
COVID-19.
no. You just
Okay,
go
let
back to the
me open
slides. I
my.
can just tell you.
Do you see this?
No,
Did
just
you see this?
no. Yeah, but I think you, yeah, this
Did
is
you see
from,
this?
that's where we lost you. No, the previous slide, COVID-19.
This one?
This, yes, if you could pick off from
All
here,
right.
that would be great. Okay then, thank you.
Let me know when I'm live.
You are connected. Thanks.
All right. Okay, great. Okay. Sorry, everyone. I'm not sure what happened, but it seems that I went offline. But I'm back now. That's a good news. So I was told that I think you lost me somewhere on this slide. So I will just try to go through this again. In fact, I went to another slide as well, but it seems you probably didn't hear that. Yeah, I was actually earlier, I was going through the different type of DNS threats and abuses and so on, and also actually went in detail to mention about how the domain names can be misused and abused and so on. So I was trying to say that whenever there is some incident, say like some activity out there in the world, these kind of abuses increase, right? Especially nowadays, we are having this COVID-19. So you will see a lot of abuses around this particular COVID-19 issue. I mean, this could be common to not only just COVID-19, any social activity that you take. It could be, say, a sporting event, or it could be some festival, or it could be some, election or anything, right? These kind of abuses tend to increase. So miscreants, attackers might get, domains and then trying to, I mean, I'm not saying everyone. There could be some legitimate cases as well. Say, for example, if there is COVID-19 for legitimate purposes, someone could be buying a domain and they could be running something legitimate, behalf of whatever the situation. But there could also be abuse situations as well, trying to get the advantage over the situation and then try to take the advantage over that, right? So same thing happened with the COVID-19 as well, because we have been we have a project that we could measure these different type of abuses that has happened since last year, right? Since the COVID was started. And that's what I wanted to share you, so that you know exactly these kind of things do happen in the world, right? So whenever there is some incident, you need to be take some extra precautions. I mean, this is a good example for that, especially during COVID-19. You see there are lots of domains were found. Basically, they were used to register certain certain say COVID related names, based on COVID related names. And then they could be, it could be used for selling some counterfeit products, or maybe selling some fake vaccines, or selling some fake masks, or things like that, right? Whatever. And then people might just go to these websites or go to these domains, and then they could get, probably it could be even malware sites, right? So you could get infected with malware and things like that, because people are hungry for information, or people are trying to, they go and look for information, or look for facts, or look for numbers and things like that. So people might be visiting all these websites and so on, so easily someone can run some malware on it, or try to sell some counterfeit products and fake products and things like that. Okay, so the methodology what we have been using to identify the suspect domains was, now in ICANN, we have got contracts with all the generic top level domains, which means like .com, .net, and so on, the generic ones. Currently there are, including the new GTLDs or new generic ones, currently there are over 1,000, somewhere around 1,200 top level domains. So we can then take the measurements based on those zones, right? Zone files of those top level domains, say the .com zone file or .net zone file and so on. Okay, and then some country code top level domains, some CCTLDs, they have voluntarily joined this project, which means because ICANN doesn't have contracts with the country code top level domains, so it was more of voluntary for them. So there were some country code top level domains who could just volunteer and then provide their zone files, so that we can carry out these measurements even using their zone files. So the advantage for them is that they can also identify how much of abuses happening in their zone files. So so initially what we have done was basically, we have taken, the pretty common words that one would register in say if someone is some miscreant is registering a domain, they could most likely, if they are being used for some abusive purposes, they could be trying to use, I mean, again, as I said, this could be even for legitimate purpose, but we have to filter those out, right? So someone could be using a domain name like COVID, or the keywords could be having things like corona or pandemic. These are some special keywords they could be using. And then we will also have to add some what we call boosting seeds, which means some related words. Say in this case, if you consider COVID, there are some related contextual words like lockdown or SARS or things like that. We could add those into into the process as well. And then there are, these words also can be translated because, as I said, the names may not only be in English, the names could be in different languages as well. So we may need to consider different other languages also. And then there are things like homoglyphs. I gave some examples about homoglyphs. Say someone could be actually registering a domain instead of COVID. Someone could use maybe C0V1D, right? This could look like COVID, right? And especially, if you're looking in, as I said, if you're looking in a mobile phone screen, you may not be able to see the difference between the 0 or O, or you may not be able to see the difference between 1 or I, right? So that's why we have to add those type of homoglyphs as well into this process, right? And then this will be compared against some of the what we call a love list and feeds, so that we know. I mean, we can then filter out some genuine words. Say, if you consider a word something like coronation, which has still corona, then that we should not take that into account, because that is different. The context is different. And then we should also use things like Punicode. Punicode means the ASCII conversion of a local language script, because sometimes they could be still registering using the ASCII code as well, right? But of course, you can have the applications to convert back to the exact script. So we need to consider all those different variations related to, and then the surrounding context related to a domain name, and then try to analyze where we think that most likely these domains have some possibility of abuse or misuse. So during last year, from like January to the end of 2020, around 248,000, 250,000 domains were identified. You can see in the blue line, but these were all the matching criteria. But then obviously you can see that during mid of the last year was quite high, because that was the time that around mid of last, like April, May, around this time, that's where a lot of countries were locked down. People were trying to order things online, and a lot of things, the work from home thing started, and people just bought a lot of medications, medicines, vaccine. Sorry, the all these different type of medications online. So because of these kind of things, the mid of the year, you could see some higher amount of registrations during that time. And then, throughout the year, you could see around 250,000 or so domains identified. And then again, this does not mean that all these registrations were sort of abuse registrations. There are quite a lot of legitimate ones as well. So once you filter out all the legitimate ones, finally we could actually filter out around 2,500 or so high confidence reports. So based on, because these things will also be basically feed into some external reputation systems, right? So for example, to analyze malware, VirusTotal, we get a feed from VirusTotal, and similarly there are a lot of other systems that could give us feeds about the reliability of this particular domain. And then based on those feeds also, we do filtering out, and then finally we sort of narrow down to something like 2,500, because there could be some false positives involved here as well. And then finally these kind of high confidence reports are being sent to the appropriate registrars so that they can take appropriate action against those abused domains, because the registrants, they know the registrants and so on, right? So I was just trying to actually explain this whole thing, just to let you know that whenever there are some incidents out there, the DNS abuses can increase, especially during this time, this COVID time, because we tend to do a lot of things online now. The miscreants, they can try to abuse DNS, and they can try to register different domains for different abusive purposes. Okay. So yeah, this is again, just for you to get some idea. About 60% of those related domains that we found, they had some relation to 4 keywords. We found that COVID or mask, corona virus. So most domain names were registered with these kind of keywords. Also, you could see that mostly they were in English, but then there were also different other languages as well. But then again, we only have access to the generic top level domains like .com, .net, and so on. But still, that counts to about 200, close to about 200 million domain names. That's quite a lot, actually, right? Something around 190 million domain names or so. But then only a very few country code top level domains, they have volunteered to provide their zone files, but there are quite a lot of CCTLDs or country code top level domains who did not, of course, who has not joined this project yet, but then those are not measured here. That is why you don't see too much of other different language and languages here, right? Because country code top level domains are pretty less. But the whole idea here is that for you to get an understanding that domain name abuses are real, domain name threats are all real, that's all happening, and we can easily get caught to many of these things, right? Okay, so best practices in securing DNS, then now you understand, now you know that there are quite a lot of risks involved, threats involved, abuses involved in the DNS, and it is very important to secure our DNS. So what are the best practices that we can take for us to actually secure our DNS infrastructure? Now, if you are just a normal user, obviously, many of these things may not be applicable to you. But if you are managing your DNS, right, especially because that is why we kind of, we have different sessions. I mean, last month's session was mostly for general public, who want to understand about DNS, the fundamentals, and so on. But then, especially if you are managing DNS, right? So we are assuming that today most audience could be maybe managing your DNS infrastructure or managing your DNS servers and so on. Many of these best practices are applicable to you. Okay. One thing is actually I have put on top, this is about deploying DNS security extensions. Now, we spoke about a lot of abuses related to, I explained you about cache poisoning. I spoke to you about DNS hijacks. I spoke to you about redirections. I spoke to you about, all sort of different, compromises. Now, deploying DNSSEC is very important. That is actually a security mechanism to protect DNS data. So this is a very good practice. And in fact, if you have not still considered deploying DNSSEC in your domain, I think it is quite high time that you should consider deploying DNSSEC in your corporate domain, in your organizational domain. And especially if you are an ISP, if you are a service provider, you should also try to deploy DNSSEC in your authoritative servers as well as recursive servers to do the validations. I will come back to this later in more detail, because in fact, our next session, the part 3, we are going to focus more on to DNSSEC, right? So that you know exactly if you want to deploy DNSSEC, how you can do that, right? So what I want to actually at this point of time, pay attention, consider the security mechanism, and try to deploy that in your infrastructure. Secure user interfaces. Always when you provide some interfaces to the users, always try to provide secure interfaces to the users. I have seen actually a lot of websites even do not have SSL certificates nowadays, right? So even you don't have SSL certificates, HTTPS is not there, right? So you need to understand that even if you don't have a SSL certificate, whatever you say, if you are giving some username and a password and things like that, that can be captured in clear text because it's not encrypted. Okay, so consider these factors, and also, providing a proper secure user access interface is also very important to to the systems and so on. Registrar locks. These are also some good practices. Earlier, I was talking about in case if your credentials are being compromised, right? In case if your credentials are being compromised, an attacker can gain, basically get into your portal. They will have the portal access. They can change all the DNS settings, they can change the name server settings, they can change the mail servers, they can change, all the other web servers and things like that, right? And then you may lose control of all those. And also they may transfer your domain from one registrar to another registrar without your knowledge. So this is also why it is important. There are things called registrar locks. So if you enable these, then in case if someone is trying to transfer the domain, then you will be notified, and then there is a certain authentication process that you have to carry with the registrar to enable this whole transfer, right? So you, in case if some attacker get hold of into your portal and then try to transfer the domain, then that may not be possible if you have enabled the registrar locks. Monitoring diagnostic tools. These are also good practices that you should always carry out, right? You should always have some proper tools to monitor your DNS and the traffic, and basically have some monitoring to see what sort of threats and what sort of behaviors, and in case if the query load is getting more on a certain day, things like this, some anomalies and so on. Okay. Network and server redundancy. It is quite important again if you have multiple servers. Say you have you're operating your own DNS servers, and if you have multiple servers, you should not put all those servers into a single, say, single subnetwork, right? Or a subnet, because if you put all your name servers into a single subnet, then in case if that subnet is being attacked, or in case if that subnet is down, then all your name servers will not have any accessibility, right? It will all go down. And also, even if you put into different subnets, avoid putting everything into say a single rack in your data center, because if you could be having your name servers in different subnets, but then if you have everything in the same rack in a certain data center, then you could still be exposed to natural disasters, right? Fires and things like that. And then if the data center gets caught to a fire, and then if you have all your name servers in the same data center, then all gone, right? So that is why having some name servers in different data centers also will give you some redundancy. These are all good practices. Secure zone transfers. This is again, if you are running multiple DNS servers, it is also very important to make sure that DNS databases across all those multiple servers are consistent, because consistency is very important in DNS. We cannot expect one server to give one answer and another server to give another answer, right? So consistency is quite important. And also you have to say, if you have some primary servers and secondary servers, if you're doing transferring the zones or the data from, say, primary to a secondary, we have to do some secure transfers, because otherwise, if there is some man in the middle type of attack, or if there are some integrity related issues, change the data, these kind of things can happen, then that will be a problem. So that is why we have to have some secure zone transfers. There are some certain mechanisms involved, things like transaction signatures. So rather than creating some IP-based access control list, you could try to create some access controls based on keys, because we can use keys for better security. So these are all good practices. And then authoritative servers must answer authoritatively. Why? Because if you are running, say, if you are running a DNS server, we know that now there can be different type of DNS servers. There could be recursive DNS servers, or there could be authoritative DNS servers. If you're running authoritative DNS servers, have only the authoritative function, right? Don't sort of try to mix it and have, because in some networks, they run DNS servers that can do both authoritative as well as recursive. Sometimes this is not really necessary unless you really don't have much resources. It is always a good practice that you separate these functions, right? If it is only running as an authoritative server, only provide authoritative answers. That's all, right? Similarly, if you are providing recursive servers, you should only allow recursion. That's all, right? Um, and also allow recursion only to designated clients. Earlier, I explained to you that we should not allow open, anyone should not be querying your recursive servers. Always, it's a good practice that you have some access controls and allow only the relevant clients, right? Because you could be having a certain customers, so you don't want to give access to everyone out there in the world. You could only be able to give access to your clients. And then update DNS software. I think I already told you about this. Make sure that you have updated DNS software, and also don't put the same software across all your name servers. Always support technical standards and compliance, because especially if you are doing some purchasing, buying, procurement, and things like that, always try to have some proper standards and compliance into your processes. Maybe if it's a tender process, if you're buying some certain products and things like that, always consider the compliance, the standards, whether it can meet all these things. What about services? Even things like SLAs, service level agreements. If you are outsourcing some functions to other parties, um, consider the SLAs in case if something goes bad, in case if they don't provide you the expected service, what is how you're going to deal with it, and what is the service level agreement with them. So all those things are important. And then have plans in place to deal with attacks. So always think that you can get attacked at any time, and then be prepared for that. That is important. If you have things like it's just like taking backups, right? So you probably take backups and so on, and then you test those as well, right? That is important. So even when you manage your infrastructure, make sure that you do all those things, and not only that, but also test these things regularly, because we could be doing all those things, but when really it happens, if we have not done testing before, we could be in a trouble, right? Especially, you should be doing some drills and testing and so on. And basically have some good cyber hygiene. That is what we wanted to highlight here. Have some good cyber hygiene. Even physical security is important. If you don't have physical security, it's no point doing all those things what I just mentioned, if you don't have physical security, because physical security is above all those layers, right? You have to make sure that who can have access to your data center, whether you have proper access key to your data center. It could be a smart card, or it could be a proper secure access, and who can do some administrative functions from can anyone do administrative tasks from any terminal in your data center, or are there any designated terminals, things like that. So these are all physical security stuff which you should also consider. These are all good practices. Okay, so when it comes to incident response, I just want to quickly go through, because we lost a little bit of time earlier. But important thing here is actually, if you are handling, say, if there is some incident, you have to know that whom you are dealing with, right? I told you in DNS, there are many parties involved. You could be dealing with a registrant, you could be dealing with a hosting provider, or you could be dealing with ISP, right? Registrar, registry. So you have to identify who the right party is. In my last session, I also went through different entities, the different stakeholders in DNS, so that in case if there are some abuses, you know whom to lodge these abuse complaints, right? So if there is some abuse, then you have to deal with that particular party and try to lodge the abuse complaints and deal with them. And also you need to identify what is the goal of the action. Say, for example, if you are taking a certain action, I mean, this action could be maybe shutting down your network, or shutting down, or maybe you're shutting down your name servers, or basically, if you have found out who is running these name servers, you're trying to take over that. Whatever action you are doing, you need to have some proper plan, right? And also you have to synchronize with, because it may not only be you who is doing this. Say, for example, if there is some incident that happens, and if you work with a law enforcement agency, or if you work with CERT, right? If you work with CERT or law enforcement, they could also be doing some actions against this, right? So they could also be having some certain plans in this whole process. So you have to actually work together collaboratively. Otherwise, if you do something totally different, this might spoil the work that is being carried out by the CERT or the law enforcement and so on, right? And also you have to work together and then see when to act and what is the right time to act and so on. Okay. And then also the things can get quite complicated, especially as you all know, in the internet, everything doesn't happen in a certain geographical boundary, right? It's all a big network. Basically, many countries could be involved, different jurisdictions could be involved, different laws could be involved, right? Some servers could be in one country, some servers could be in another country, the victim could be in another country, right? So when you have to deal with many jurisdictions, you have to really work closely with law enforcement. And then because you may have to then work with law enforcement in other jurisdictions as well, or the legislative, you have to probably consider the legislations in other different jurisdictions. So all these things need to be addressed, actually, properly looked into when you're handling incidents. And then taking the action, right? So taking the action, sometimes you could still take actions based on the usual terms and conditions that the registrar normally provide to a registrant, or because sometimes the ISPs, registrars, and so on, they provide things called acceptable use policies, right? So they have their own policies in case if there is some incident, if some of their registrant is running a phishing site, or if they are running a malware hosted site, then what are the actions that they are going to take against them? So these things could be listed in their agreements, so you may have to refer to those agreements, or you may have to even get into some further documentation, or even at a higher level, you could probably have to deal with legal or courts, or might have to get some court orders and things like that with the law enforcement, right? So this could go into different levels as well. So you will have to consider all these aspects when you deal with the incidents. All right, I think just before we stop, I just want to very quickly, because this is DNSSEC, we are going to cover in detail next week, but I just wanted to give a sort of very quick brief today, so that you know what we want to cover in detail next time. Now, I told you why we need DNSSEC. So DNSSEC stands for DNS Security Extensions. Now, this is to protect DNS data. Now today, during the whole session, I was explaining about different type of abuses that can happen in DNS. What type of security attacks, what type of security incidents and risks and threats and so on that can happen in the DNS space. Now, DNSSEC can address some parts of those issues. So to avoid, say, for example, the things related to DNS data. If you remember, I told you that if you consider the proper secure system, you need to have things like integrity of the data, authenticity of the data, right? So for example, if I am sending you certain data, you have to make sure that the data that I'm sending you is not modified in the middle. Or if I'm sending you some data, you have to make sure it is really coming from me. So these kind of things can be solved or can be handled by DNSSEC. So DNSSEC will validate whether it is really coming from me or whether the data is not modified in the middle and so on. So this can protect a lot of attacks like phishing attacks, cache poisoning, those hijacks and things like that can be protected using DNSSEC. So that is why DNSSEC is a very important DNS security mechanism that we can deploy or implement to protect our DNS data. That also doesn't mean that implementing DNSSEC doesn't mean that you're protecting your full DNS infrastructure, right? You still have to apply various other security mechanisms at different levels, different layers, and so on. I told you earlier, like, physical access, who has access to your servers and things like that. Even if you have DNSSEC, that unless you protect those things, that will not be helpful. So like this, there are different other aspects as well in terms of security, but DNSSEC can only provide the integrity and authenticity of DNS data, which is a very important component in DNS, right? So whole thing, the whole concept behind DNSSEC is actually we use cryptography, right? So we can sign the data related to DNS. So because in DNS we deal with databases, DNS data databases. So if I am keeping some DNS database, right, I can sign my DNS data using my, we have these asymmetric keys where we have private and public components. So I sign my data using my private keys, and then then I will generate signatures, and then those signatures can be validated using my public keys. So to do that, I have to publish my public keys. So that's the basic concept behind DNSSEC. And so the objective is for us to protect our DNS data and to achieve authenticity and integrity of the DNS data. Okay. So if you deploy DNSSEC, now in a typical incident, say if a client is visiting his or her bank website, say in this case majorbank.com, right? We don't know, I mean, as a client, we don't know, the recursive server will give us, right, the correct IP address of the majorbank.com. If we get the correct IP address, that's fine. We can go and visit the correct bank website. But if we get a wrong IP address, like which is shown in the orange color here, the correct one is in blue, the wrong one is in orange. So if we are returned with a wrong IP address, we will end up in going to a wrong website, which is managed by the attacker. This is where the user can give wrong credentials and lose all their credentials and so on. But if we implement DNSSEC with DNSSEC, if any server provides a wrong answer, the recursive servers can check and validate whether it is really coming from the correct server and it is not modified in the middle. And once that is validated, if it only can validate, then only the answer is given to the client. If the answer cannot be validated, then the answer will not be given to the client. So in this case, at least the recursive server operators can make sure they are giving right answers to their client. So the client will visit the right places. So that's the whole objective of DNSSEC. Now, this is just to show you some statistics globally. all the TLDs, right? So you can see almost like 90%, all this green space, they have almost like 90% of the top level domains out of like 1,500, almost close to about 1,300, 400 or so. They have deployed DNSSEC at the top level, right? So like .com, .net, .lk, that top level, around 90% of the top level domains, they have signed their top level domains. That means their zones have been digitally signed, which is a good news, because if you consider the top levels like .com, .net, .lk, and so on, almost 90% of them in the world, they have deployed, they have signed DNSSEC, right? Their zones have been signed. If you consider country code top level domains or CCTLDs, that figure is something like 50% or so, right? A little bit over 50%, because some countries, country specific ones, they have not yet signed or not yet deployed DNSSEC. But again, I'm trying to relate this to Sri Lankan context, because in Sri Lanka, the country code top level domain is .lk. So .lk has deployed DNSSEC. So .lk is in this green space. So because they are in green space, which is good, because if your organization has got a domain name under .lk or under .com, either way, because .com also has signed. So if you have if your domain name is something.lk or something.com, then you can deploy DNSSEC, right? You can sign your domain. So if you're managing your DNS, or if you have already outsourced to another party, they can deploy DNSSEC. This is actually just to show you some statistics again in the world in terms of validation. So validation means, remember I told you that the recursive resolvers managed by ISPs or mobile operators and so on, they have to make sure that they are giving right answers to their client. So they should be able to validate these answers. They should be able to basically do DNSSEC validation and provide right answers to their client. So currently, you can see, if you see the statistics worldwide, you will see, around 26% of these DNS queries are going through recursive servers that can validate DNSSEC, right? So which means about 26% of the DNS queries, they go through DNS servers that validates DNSSEC, right? So which means if you take 4 queries, 1 out of those 4 queries are DNSSEC validated responses, which is good, right? I mean, we still have to go further, furthermore, but at least we're doing something, right? So many of the resolve operators, they are validating their queries. So the worldwide figure is something like 26%. But I also actually did some, if you come to Asia, generally, like, all the queries, DNS queries coming from Asia, DNS validation is something like 24%, almost like, 26, 24, pretty much around same. But I also went through the statistics. These statistics were developed by, measured by APNIC Labs. I also actually had a look at the stats from Sri Lankan point of view, from Sri Lanka. So at the moment, based on sort of today or so, the validation rates from Sri Lanka is something like 4%, right? So comparing to the world, which is like 26%, in Sri Lanka, it's something like 4%, so quite less comparing to the world average, right? So this is something that I think especially the resolve operators should consider. If any ISP is listening here, or if any DNS, maybe corporates who are running their own DNS servers in Sri Lanka, or even the mobile operators who are operating DNS resolvers and providing it to clients, try to validate your queries, right? Try to enable DNSSEC so that your servers will enable, and then you can give right answers to your client, so that you can make sure that clients will not go to phishing sites and malware sites and so on, and at least you can protect your clients. I think with this, I just want to give some sort of guidelines, what you can do if you are from a registry or registrar operator, in case if some registry operator is listening. But I in Sri Lanka, as I said, .lk they have already deployed, so that is fine. But if there are some registrars or DNS operators, try to offer DNSSEC services. And then if you are a corporate, if you are a company, if you are a bank, or if you are any organization who manage your own domain name space, try to sign your corporate domain names. That is quite important, which means try to deploy DNSSEC. And then enable DNSSEC validation if you're running some corporate DNS resolvers, because some companies, some organizations, universities, banks, and so on, they run their own DNS resolvers in their network. So try to enable DNSSEC validation in your network, in your DNS servers. If you are ISP, make sure, or if you are a mobile operator, make sure you enable DNSSEC validation on your ISP resolvers or mobile operator resolvers, right? If you are from government, if you are a policymaker, encourage DNSSEC compliance, because you can come up with some guidelines and things like this. Even if you are within an organization, you can have some internal security policy that yeah, we should enable DNSSEC in our resolvers, in our servers. So we should, if we are managing our corporate authoritative service, we should try to sign our corporate domain names. You can have some compliance or policies around this. If you are a normal user, always trying to request these type of services from your ISP or from your mobile operator or from your resolve operator can help, because at least then they can, if they get a demand from the client, from the users, they will try to implement that. And in general, for everyone, have some awareness about DNSSEC, and there are training and education offerings around this as well. And this is also why in the next session, we will try to allocate the next session to talk about DNSSEC, and if someone is interested, how you can deploy this. I think that's all. I think we have taken a little bit of time, especially extra bit of time, because we lost some connection in the middle. But I hope that this session has been useful. If there are any questions I can take, or otherwise you can even email me, and I'm happy to answer your queries.
Thank you, Champika.
Over to you, Alan.
Thank you so much. Well, it's been an amazing session as usual. You've gone in so much of detail that to make things very clear. So thank you for that, and thank you for taking your time in explaining all the concepts. We kind of started off with related to confidential integrity, then we moved on to the threats and abuses and the risk. We spoke things like type squatting, namespace risk, redirection, DDoS. We spoke about vulnerabilities in softwares, something like patch management, which organizations need to look at. Then you spoke about DAAR, the COVID-19 issues, and how attackers take advantage of incidents. Then we spoke about best practices. You went through all of them, and finally spoke about DNS objectives. And so thank you so much, Champika. It's been a very elaborative and informative session. There are a few things. I think we've just run out of time, but let me just ask you a few questions, if that's okay. The difference between registrar, registrant, and registry, just in short, I mean.
Okay, so say you want your own domain name, right? So when I say you yourself, right? So you want to get your own domain name, right? You want to buy it, so you become the registrant, right? And say you're going to come to me to buy that, and I am your registrar, because typically registrar is the one that offer that service for the registrant. So registrant can come to a registrar and buy a domain name. But in some cases, actually, especially if the registrar is very big, there could be an in-between entity called resellers as well, domain name resellers. But still pretty much the similar sort of, because basically you buy the domain name from me, and then I do your registration process and everything. But I'm doing that for behalf of registry, right? Because there's another one level above me, because they are the registry, like for example, .com, for example, right? So I will get all this information from you and then send it, basically, provide that to the registry so that they are the ones who will put that into their database, or what we call the zone, right? If you remember in the last session, we went through zone files. So in actual fact, all your details will be updated in the registry zone file via myself. So I am the sort of intermediary person as the registrar. So registrar is the intermediary entity, and then registrant is the one who want to get the domain, and registry is the one who manages the actual DNS zone itself, the authoritative zone.
So
Hope
thank
that
you.
clarifies.
Thank you, Champika. Thank you for explanation. So with that, let's wind up the session for today. Once again, on behalf of Sri Lanka CERT, let me thank Champika Wijayatunga from ICANN for his time and for the session. Thank you so much. And I just do want to remind the viewers that the next session will be again in a week or so. We'll keep you posted with the date on our Facebook page. So that we'll be covering things like DNS signing, DNS validation, key management, DNS tools and management. So are we going to have any sort of practical on this, Champika?
Actually, no, we may not, because within 1.5 hours time, we may not be able to go through a lot of hands-on stuff, but we can probably, as a separate training or something, we could try to plan some hands-on later on. Maybe not in the next one, but as a separate training.
Right. Thanks for the clarification. So that's it. Thank you so much, everyone, those who have joined us. If you missed any part of the session, please visit our Facebook page or our YouTube channel. We will be posting them, the recording on those channels. Thank you, everyone. Thank you. Bye-bye.
Yeah. Thank you all. And very nice, actually, again, meeting you all, at least in a remote way. Thank you.